questions 5 through 7 on the 2012 grade 12 Euclid math contest. Triangle ABC has vertices 0, 5, 3, 0, and 8, 3. Determine the measure of angle ACB. So 0, 5 approximately here, and we'll call that A, 0, 5. And then we have 3, 0, so approximately here, and that is my B. And then we've got 8, 3, so somewhere out here is 8, 3, and that is C. And this triangle is what they are asking us to figure out one angle for. And that angle is ACB, so this angle right here. So I'll call that theta. Well, there's several approaches to this question. I'll just use something that is pretty standard, finding the sides and then using the cosine law. So let's first find side AB, and that can be figured out pretty quickly with the distance formula since we have 2 points. So 3 minus 0 squared plus 0 minus 5 squared, all under the square root sign. And that is going to be 9 plus 25, and that is square root of 34. So put that here. That's the length of that side. Now let's calculate the next side, AC. AC, it's going to be 8 minus 0 squared, and then plus 3 minus 5 squared, all under the square root sign. That's going to be 64 plus 4, and that's the square root of 68. So square root of 68 goes here. And then the last one is BC. So 8 minus 3 squared plus 3 minus 0 squared. And that is 25 plus 9 again. And that's the square root of 34. So that's right here. And then now we can use the cosine law to figure out that angle. So the cosine law, using that angle, it will be root 34 squared is equal to root 68 squared plus root 34 squared minus 2 times root 34 times root 68 cos theta, like that. And then now all we have to do is isolate for cos theta. So let's get rid of all this. This is 34, this is 68, this is 34, and this is going to be 2 root 2 times 34, because that 68 can be broken up into 2 times 34. And then that's cos theta. So this 34 cancels with that. So all I'm left with is 68. And if I put the negative on the other side, 2 times 34 is 68. So that's 68 root 2 cos theta. And then isolating for cos theta, I get 1 over root 2. And then theta, therefore, you can get out your calculator and figure out easily that theta is 45 degrees. And that's it. So number 5A is complete. 5B. In the diagram, PQRS is an isosceles trapezoid with PQ is equal to 7, PS and QR are both equal to 8, and SR is 15 to determine the length of PR. So our task is to figure out P to R, that length right there. And then what I'm going to do is drop some perpendiculars. So P down to the bottom there, and Q down to the bottom like that. And those are perpendiculars like that. So initially, we can look at this side. That's going to be 7 since it's the same as that. Now this whole thing is 15, so that means this and this are going to be 7 minus 15, which is 4. But this is an isosceles, so they're going to be equal. So this is going to be, 15 minus 7 is 8, and that has to be divided equally on that side and that side. So each of those will be 4. So this will be 4, and this guy will be 4 here. So now we can figure out PR using Pythagoras with 2 steps. First, let's figure out that and then we can use that to figure out PR. So I'll just call this M. So what I'm really trying to figure out is PM. So PM squared plus 4 squared is equal to 8 squared. So PM squared is equal to 64 minus 16. So PM squared is equal to 48. So PM is root 48. So now we can figure out the value of PR using this triangle right here. So in that triangle we have PM squared plus MR squared is equal to PR squared, like that. PM squared we just figured out was 48 over here. MR is the distance just from there to there. So that's going to be 7 plus 4, so that's 11. So 11 squared, and that's equal to PR squared. So this is 48 plus 121 is equal to PR squared. And then 48 plus 121 is 169 PR squared. And then therefore, if you take the square root, you get PR is equal to 13. Blaise and Pierre will play 6 games of squash. Since they are equally skilled, each is equally likely to win at any game. In squash, there are no ties. The probability that each of them will win 3 of the 6 games is 5 over 16. What is the probability that Blaise will win more games than Pierre? Well, we have Blaise and Pierre, and let's say we are making a table with the number of wins. There's 6 games, so we can either have 6 and 0, 5 and 1, 4 and 2, 3 and 3, and then of course the other ones that are the exact opposite, 2, 4, 1, 5, and 0, 6. Now, they tell me that this is a probability of 5 over 16, where each of them wins 3 games. Okay, well, we are interested in this scenario, these ones. And the reason is because these are the ones where Blaise wins more games than Pierre. So either 6-0, 5-1, or 4-2. Because of this very important point, they are equally skilled and each is equally likely to win any game, the probability of these 3 happening is the same as the probability of these 3 happening. So if this is X, this is also X. Now the total probability of all that happening is of course 1, right? So that means that X plus 5 over 16 plus X is equal to 1. So we can now solve for X. So that means 2X is equal to 1 minus 5 over 16. 2X is equal to, that'll be 11 over 16. And therefore X is equal to 11 over 32. And that's the probability that we have a situation where Blaise wins more games than Pierre. These 3 scenarios combined. Determine all real values of X for which this expression is true. Okay, well, a little bit of a substitution to help us. Otherwise, it'll get kind of confusing. Let 3x equal to a, and let 2x equal to b. So this expression really is 3x times 3 to the power of 2 plus 2x times 2 to the power of 2 plus 2x. And that is 2x times 2 to the power of 5 plus 3x, like that. So 3x is a, and then 3 squared is 9, so that becomes 9a. And then 2 squared is 4, and then 2x is b, and then I've got a b. And then this part is 32b, and then plus a. So combining everything, all the like terms, I will get 8a on this side, and on this side I will get 27b. So obviously a little bit easier to digest. And then at this point, I can substitute back in. And if I do, I get 8 times 3 to the power of x. And that is equal to 27 times b, which is 2 to the power of x. Okay, so now I bring in my logs. This is going to be log of 8 times 3 to the power of x is equal to the log of 27 times 2 to the power of x. Okay, now there's that log rule that you can add them if it's two things that are being multiplied by each other. So it becomes the log of 8 plus the log of 3 to the x. And similarly on that side, it becomes the log of 27 plus the log of 2 to the x. And then another log rule allows you to put those exponents out front. So this remains the log of 8, but now it becomes x log 3. And this remains log of 27, but this becomes x log 2. So now all I have to do is isolate for x. I can do that first by bringing it all over to one side, minus x log 2. This is the log of 27 minus the log of 8. And then this, of course, factors log of 3 minus the log of 2, like that. And then this remains log 27 minus the log of 8. And then finally, if you isolate for x, you will get log of 27 minus the log of 8 all over the log of 3 minus the log of 2. So get out your calculator, plug in these numbers, and when you do, you get a value of 3, exactly 3. And that's the only one. They say determine all real values, so it makes it seem like there's more than one, but there isn't. And I also encourage you to verify. Take the value of x equals 3, plug it back into here, and see if the left side equals the right side, and it will. In the diagram, triangle ABC has AB equal to AC, and BAC is less than 60. Point D is on AC with BC equal to BD. Point E is on AB with BE equal to ED. If angle BAC is theta, determine BED in terms of theta. This is a question that involves angle chasing. So we are given one angle, and that's BAC, and that is theta, and we have to figure out all the other angles in terms of theta. So we are given some clues that will help us, of course. So let's begin. First of all, we know for a fact that AB is equal to AC. So AB is equal to AC. That means that is an isosceles triangle. So that means this angle is the same as that angle. So if I call this angle, let's say alpha, then that angle is also alpha. So I'll just put that there. That is alpha. So in terms of theta, it would be alpha plus theta is equal to 180. So 2 alpha is equal to 180 minus theta, and therefore alpha is equal to 90 minus theta over 2. Okay, so far so good. Now we also know that BC is equal to BD, right here. BC equals BD. So if this is equal to that, that is also isosceles. So if this is isosceles, then this angle is equal to that angle. So that I've already labeled alpha, so this is alpha. Okay, so now I have to look at that angle. That angle in terms of alpha, I can get. That angle is what? DBC, this one right here. So angle DBC plus this alpha and that alpha, so plus 2 alpha, is equal to 180. Again, so that means angle DBC is equal to 180 minus 2 alpha. But 2 alpha we just got up there is 180 minus theta. So I can put that in, minus 180 plus theta, because I'm subtracting. And that just gives me theta. Interesting. So that means that this angle in here is theta. So I'll put that there. That's theta right there. Okay. So this angle in here, therefore, will be alpha minus theta, because remember, this angle from there to there was alpha, and then this angle is theta. So this guy in here that one is alpha minus theta. Okay, so I hope that makes sense. And then finally, BE is equal to ED. BE is equal to ED, so that's another isosceles triangle. So that means this angle has got to be the same as that angle. Well, that angle we just figured out was alpha minus theta, so this is also alpha minus theta. That angle in there. So finally we get to BED, which is this guy right here, and that's what we have to figure out. So BED plus this, which is alpha minus theta, plus this, which is also alpha minus theta, is equal to 180 degrees. Well, let's see what we can do here. Angle BED. This becomes 2 alpha, of course, and 2 alpha is 180 minus theta. So 180 minus theta. And then these two add up to negative 2 theta, so negative 2 theta. And that all equals 180. So it looks like this 180 cancels with that 180. So all I'm left with is angle BED minus 3 theta is equal to 0. And therefore angle BED is equal to 3 theta. And that's what they wanted. They actually don't want the numerical value. They just want BED in terms of theta. And in terms of theta, it's equal to 3 theta. In the diagram, the Ferrous wheel has a diameter of 18 meters and rotates at a constant rate. When Colapo rides the Ferrous wheel and is at its lowest point, he is 1 meter above the ground. When Colapo is at point P, that is 16 meters above the ground and is rising, it takes him 4 seconds to reach the highest point, T. He continues to travel for another 8 seconds, reaching point Q. Determine Colapo's height above the ground when he reaches point Q. Let's draw some lines and try to explain this. I am assuming this is the center, so I'm going to draw a line from that point to T. Then I'm going to draw another line from that center to P, and then I will draw another one to Q, and then one line across like that, and I think that should be sufficient for now, and one more line from that center to that point right there. That is opposite P. Okay, so now we have to carefully label the distances, because remember, there's some discrepancy with regard to top to bottom. It's not exactly 18, it's 18 plus 1, right? Okay, so let's label this now. They tell me in the question the diameter of the Ferrous wheel is 18. So if the diameter is 18, then that means the radius is 9. So when you draw lines from the center to any point, those are going to be 9 in length. So that's 9, right? This is 9 as well. Now, the distance from top to bottom, so this is T, and the very top all the way to the very bottom, be careful, is not 18, it's 18 plus 1, this one little guy there. So top to bottom is actually 19. So all the way from the very top to the ground is 19. Now they told me that this distance is 16. So that means this has got to be 19 minus 16, so that's 3, right? This 19 minus that 16. Okay. Well, the radius of that circle is 9, so if that's 9 and that's 3, then that means this distance from here to here has to be 6. Okay? And then the way I've drawn this triangle is purposely to make this a right angle, and therefore I can use trigonometry. And I will concentrate on this angle right here, so I'll call that theta. So I can use cos. Cos of theta is adjacent over hypotenuse, so 6 over 9. Get out your calculator, and when you do, you get approximately 48.19. Now, because of the symmetry of this diagram, this is also theta right here. I've done the exact same thing. And very important in this question is that it takes 4 seconds for him to go from P to T. So when he's here, to go from here to here, it takes 4 seconds. So that means it takes another 4 seconds for him to go from there to there, since that is pretty much the same. It's just a mirror reflection. So 4 seconds to go from there to there, 4 seconds to go from T to this point. We can call it whatever you want to call it, M, let's say. But then it takes him 8 seconds to go from T to Q. So from T to Q, it takes him 8 seconds. But it takes 4 to go from here to there, so another 4 to go from M to Q, like that. Okay? So since the distance that he's traveling takes the same amount of time, that angle must be the same. So that means that's theta as well. So now we have to calculate the height when he is at Q. So we have to introduce another triangle, and I'll draw a top to bottom length, and then I will extend Q to that line so that it meets at a perpendicular. And there we go. So that's the triangle, this little triangle right here, this one. That triangle will help me figure out the distance. And in particular, that distance is from here all the way down to the bottom. It's the equivalent of going from there to there. So let's draw that in to show that when you go from Q down to the bottom, like that, that is the equivalent to this guy right here. So to figure that out, I will need to figure out this distance in there. Now, top to bottom is 19, and from T to the center was 9. So that means from here to here is going to be 19 minus 9, which is 10. All right? So all I have to do is figure out this distance and then subtract it from 10, and that will give me that distance, which represents the height when he is at Q. So how do I figure that distance out? Well, again, we're going to use trigonometry. But we need this angle in here. That angle in there is basically 180 minus 2 theta, right? Because all the angles from there to there have to add up to 180. And this is theta and that's theta. So this angle in here has to be 180 minus 2 theta. And if you do that, you'll get approximately 83.62. So now we can use trigonometry on this triangle. We can call this distance, say, x, that little guy. And therefore, the cos of 83.62 will be equal to x over 9. And if you solve for that, you get equal to 1. You'll see, especially if you used several decimal places, that it equals 1. And that's it. So now the final step is to figure out the distance from there to there. Well, that distance, we'll call it height, h. H is basically 10 minus x, and x is 1. So that is 9. So the height when he is at Q is equal to 9.